Good evening, Shasta High School. This is Mr. Roberts here for Math 1 CP um, or Honors or Math 1 Essentials. Any of you could be doing these problems, just maybe at different times, different places. Question 116 says solve the following systems of equation using any method. Check your solution if possible. So for A, what I'm clearly hearing this problem scream at me is please use elimination because my x's are set to cancel just as it is, so we'll use elimination, add equal things to each side of this equation. Over on the right hand side we get 3, and on the left hand side we end up getting 9y, right? 3y and 6y is 9y. Of course the negative 2x and the 2x become 0, and if I divide both sides by 3, y is either 3/9 or probably more popularly we call that 1/3. So y is 1/3. Now we need to figure out what x is. Well, there's a couple ways, right? We can figure out what x is. I like the top equation, so I'm going to go ahead and use that. It says, hey, negative 2 times x plus 3 times y, which is 1/3, is 1. Well, 3 times 1/3 is convenient because that just becomes the number 1. So this is negative 2x plus 1 equals 1. If I subtract 1 from each side, negative 2x is 0. Don't forget it's a 0. And dividing 0 by negative 2 is not a problem, right? 0 divided by negative 2 turns out to be the number 0, so x is 0. So our solution is y is 1/3 and x is 0. If I wrote it as an ordered pair, it would look like this, 0, comma 1/3. And if we plug those values in for x, right, this becomes the number, if I plug it into the first equation, negative 2x times 0, that would become 0. And then 3 times 1/3 would just be the number 1. So I get 1 equals 1. It definitely checks. In the bottom equation there, 2 times 0 is still 0. And 6 times 1/3 is equal to 2. So it checks as well. So let's turn our attention now to B. B has y equals 1/3 x plus 4, and x is negative 3y. This looks like a pretty clear-cut case for substitution. So I can see that in the second equation I'm told that negative 3y is what x is. So I'm going to replace x in that first equation with that value. So this is going to become negative 3y. So here it is. I'm taking the first equation and I'm transforming it using substitution. So it becomes y equals 1/3 times negative 3y plus 4. When I multiply negative or 1/3 times negative 3, I get a negative 1. So this is y equals a negative 1y or negative y plus 4. I can add y to each side, giving me that 2y is 4. Therefore, y would be the number 2. Now that I know y is 2, this is a great way to figure out what x is, right? X is negative 3 times 2. So x should be negative 3 times 2, or x is negative 6. So my solution looks like negative 6 for x and 2 for y. And if I plug those in real quickly, in the first equation, if I have, let's see, x is negative 6, 1/3 times negative 6 is negative 2, and negative 2 plus 4 is positive 2, so that totally checks in the first equation. And then if I take y, which is 2, and multiply by negative 3, it does give me negative 6, so it checks there as well. That's definitely the solution to that system. On to part C, and I am once again thinking the substitution because this turns out to be a replacement for y, right? Y is 3x minus 2. So I'm going to plug that into the first equation there. So that first equation becomes 3x minus, and then I use the parentheses, 3x minus 2, and that equals the number 7. If I distribute this negative 1 to each of these terms, I'm sorry, to each of these, they're terms, pushing this negative 1 factor, and it becomes 3x, and then minus 3x, and then plus 2 is 7. This is 0, so I just got the expression 2 is 7. And say, what? This is clearly a contradiction. So if I was to graph this system, what I would be looking at are two parallel lines, right? They don't intersect at all, ever. They have nothing in common. They have no XY ordered pairs in common. So there's no solution here. And finally, for part D, I'm going to go ahead and push through a factor of -3 in that top equation. That will give me an opposite x with the bottom equation. So each side I'm multiplying by -3. When I do this, the first equation transforms to -3x and then -6y, and that would equal -3. And then down below, I'll just rewrite the second equation. It is a positive 3x plus 5y, and that equals 8. So at this point, we're using elimination. The x's do eliminate, -3x and positive 3x. So I end up with a negative y equals, when I combine -3 and 8, I get a positive 5. Therefore, y has to equal -5. And I now need to figure out what x is. I guess I'll just grab the second equation here. It says 3 times x plus 5 times y. So I've got a 5, and then I'm multiplying that by y, which was -5, and that should equal 8. So 3x minus 25 equals 8. Therefore, 3x equals that would be positive 33. And when I divide both sides by 3, I get that x is the number 11. So my solution should be x is 11 and y is -5. And of course, it's important to plug that in and check. So if I plug in the 11, I guess I'll write this down this time. So I'm just going to look at the first equation and then the second equation. So when I plug in 11 into the first equation, it becomes 11 plus 2 times -5 would be -10. And sure enough, when I combine those two, I do indeed get 1. So that checks in the first equation. The second equation, 3 times 11 would give me 33, and then I've got -25. And actually, that's how I arrived at that number, -25. So when I take 33 and subtract 25, I do get positive 8. So yes, that checks as well.